Hello and welcome to IOCODES. This is a complete beginner series in Java. Now, if you are just joining us, it's not too late. Please, I want you to take your time, subscribe to this channel, and give this video a thumbs up, and also ping that bell icon so that whenever I give the next updates, you get notified. So, in the previous video, we looked at assignment operators. Now, in this video, we'll be looking at precedence rule and type conversion. So type conversion has to do with typecasting, but before then we have to look at precedence rule and see how things works when we have a couple of mathematical operators in a given expression. Now before we get started, there is a term in mathematics known as the BODMAS. What the BODMAS stands for is bracket of division, multiplication, addition, and subtraction, as my memory may have it during my college school days. Now, that same concept applies to some degree in programming. It applies very well in programming, but it has its own kind of pattern that it follows that differentiates it a little bit from programming, from mathematics and programming. So I'll give an expression by creating a variable of type int, and I'll call that variable expression. And I'm going to give it a value that is going to evaluate the series of operations. So I'll start by saying 5 times 3 plus 7 minus 9 divide 4 and semicolon. So you see we have a string of operation, and this operation includes multiplication, addition, subtraction, and division. And I can go as well as including another operator. We'll look at that other operator after simply evaluating this expression. So from the rule of BODMAS, following the rule of BODMAS, we can see clearly that this division is going to occur at first, followed by the multiplication, and followed by the addition before the subtraction. However, in this case, the multiplication is going to occur at first. The reason is because in Java, the precedence of the multiplication and division are equal, and because they are equal, when an expression is about to be evaluated, it's going to take the one that comes first. In this case, because both of them has equal precedence, it's going to execute the multiplication before it executes that of the division. So following that pattern, we are going to calculate this expression, give our expression a value, and then we are going to print out and see if our answer falls exactly in line as that of our program when it is being run. So we have 5 multiplied by 3, that will be 15, and then we do 9 divided by 4, that will be 2. So we have 2 here, and we have 15 here. So the next will be the addition. So 15 plus 7 is going to give us a value of 22, and 22 minus 4, that was minus 2, that was gotten from this division operation, is going to give us a value of 20. So when I print that expression, we are going to get a value of 20 on our console. Now there's something I want to draw to your attention quickly, and that is due to the fact that 9 divided by 4 is supposed to give us a real number and not an integer. But however, we are not applying any typecasting which has to do with type conversion in this scenario, and our expression is of a variable of type int, so it can only hold integer value. So whatever real number that this expression is going to produce, the computer is going to discard the real part from that expression and assign just the integer part to our expression variable. So I'm going to print out the value of expression by doing south, and we'll say the value of the expression above is loop plus expression. And yes, I'll simply run this program, Control Shift F10 altogether, and yes, your class is going to run. So the value of the expression above is what, 20. Now, like I stated before, I said we can go ahead and include another mathematical operator, and that should be the modulus operator. We've looked at the modulus operator in the past, and we can see expression equals to the whole of this one more time. Control C, Control V, and I'll do a modulus. Modulus I'll say 7. Okay, see value to expression is never used. So I'll copy this just to make sure that it is used, and I'll paste it right here. Yes, let me see what the warning is all about. Variable is already assigned to this value, so I'll correct this and I'll just put 2 just to change it a little bit. Now I'll run the program one more time, and then we can see that the modulus operator will run immediately after the multiplication operator. Okay, the value of the expression above is 22. Okay, now let us check how this operator ran. So I believe it kind of expressed this modulus operation at first, or perhaps it did this one at first. When it did this one, it was 5 multiplied by 3, that was 15, and 4 mod 2 was 0, and 9 divided by 0 is 0, and 15 plus 7 give us a value of 22. So I think that is how this 22 came about, because IntelliJ has already prompted that this whole value can be replaced with just this. So instead of 4 mod 2, I'm going to do 4 mod 3, and let us see what will be our value. So we have 20 this time around. Now, the reason it is 20 is what we are going to be looking at. So at first, it did 5 multiplied by 3, and that was 15. Then I think it did 9 divided by 4, that would be 2. And then it went ahead and did 2 mod 3. 2 mod 3 will give us a value of 2, because 3 go into 2 0 times, remaining 2, and that would just be it. And then it did 15 plus 7, that was 22, and 22 minus 2 gave us a value of what? Of 20. So in short, I'm going to include all of this in a simple bracket. Let me just include them in a bracket to show you how it evaluated. And this is exactly how it's evaluated. So at first it was 5 multiplied by 3, and that was 15. And for this, it was, sorry, no, not like that. So it was 9 divided 4 at first. So it was 9 divided 4, and that was 2. and 2 mod 3 was also 2. 7 minus 2 was 5, and 15 plus 5 was 20. So I want you to play around with this stuff and get yourself familiar with the precedence rule in Java. Now we look at type conversion next. Still make use of a new expression variable, but let me convert this to a type of double. Now recall, all of these numbers are integer and we are doing a division operator. Now 9 divided by 4 is going to give us a real value, a real number, that is a number that has decimal values associated with it. But due to the fact that our former expression has a type of integer, the computer discarded the real part and just went ahead and took the integer part and stored in our expression variable. However, we now have a situation whereby the type of expression is of double. And now to correct this, we are going to typecast the integer, one of these integer that has division associated with it. So I'm going to say parenthesis open up, and I'll do double and parenthesis close. And I can copy this also, Ctrl C, and paste it before the 9 in this scenario. And yes, I'll run the program. So we have 19.75 and 19.75 printed out twice. So this is how type conversion works. Now we can do a lot more with type conversion. Remember when we looked at variables from the very beginning, we saw the different primitive data types and we saw their different range. That is the different range of values that this primitive data type can hold. So now remember that we have byte, short, int, and long as values that can hold normal integers, but they have their own specified range. So I can do something like this: byte byte b is equal to 200. The reason for that is because now bytes can only hold values in the range of -128 to +127. So going above +127, we have an error. So when I do 128, you can see we have an error. But immediately I change to 127, the error is gone. The reason for that is because the byte can only hold that particular range of value. So also applies with short and even int. So they have their specified range of value. Now, how do I convert a short variable to a type of byte? So I can go ahead and say short s is equal to 127. Now, when I want to do a byte b, I can just typecast the value of short by saying byte, by including bytes in parentheses, and then I'll just do s. S is the variable that is of type short that has a value of 1 to 2. I can also go ahead and increase the value right here to 129. But now, when I try to print out the value of byte, plus b, we'll have something printed out in the console, but this is not the real value. It's going to give us a somewhat negative value because it's going to start over from negative 127. I believe it's going to give us something like a negative Okay, you can see we have a negative 127. So what it did was it got to 128 and immediately went back to a negative 127. So let me change this to 139 and see what the result will be. So we have negative 117. So that is how the type conversion works. So basically, we don't just convert just from real numbers to normal integer or vice versa. We can also convert between values of between types that are holds the same value but they are in specified range. But we have to be careful when doing this conversion because of things like this. So we have to be sure that the value that we are trying to convert a particular type to, the value that we are trying to convert that particular type to is a legal value in the specified range. Now, for instance, you don't know that okay, 139 is not in a specified range for byte. Your program might run into a problem because at the end of the day it's going to evaluate to a negative value. So you have to be careful about that, and I have to draw that to your attention with this video. Now, as an assignment, I want you to just write an expression, get the value of the expression in the double format, and I want you to typecast that double value into an integer type, just for the sake of practicing what you've learned in this video. We have come to the end of this tutorial. I really appreciate you staying this long, and please, if you are yet to subscribe to this channel, please do so, and also turn on that bell icon, give this video a thumbs up, and peace out. I'll catch you in the next one.